Hey everybody, Mr. Bells here again. This video is for section 1-4. It's on functions and function composition, so our ability to add them, subtract them, multiply them, divide them, and then embed those functions. And then also being able to take apart relationships that aren't functions and see if we can write them as functions and what they might look like. Okay? We're going to start off with these three up here at the top. So three functions, f of x, g of x, and h of x. And some basic things. We'd have stuff that might look like this, f plus g of x, which means we're adding those functions. And then, or let me do this one. Let me stay with this, f plus h of x, and add those functions. H minus f of x, subtract those functions. F of x times h of x, multiply those functions, and then even h of x divided by f of x. Like that, okay? When we do the embedding, I'll talk about that one in just a second, okay? So here we go. F plus h of x just means we're going to add those two functions together, so that would equal x squared plus 8x minus 2, because I put the 2x and the 6x together to get 8x, and the 3 and the negative 5 together to get negative 2. H minus f of x, well, if I'm subtracting the f function, that means that's got to be a negative 2x and a negative 3. So that would equal x squared, and then positive 6x minus 2x is positive 4x, and then negative 5 minus 3 is negative 8. So that would be a subtraction of those two functions. If I multiplied those two things together, that's going to be a pretty big situation like that. Which means I'm going to go ahead and take this function right here and that function right there, and I'm going to multiply them. So I'm going to kind of write them right next to each other here, and then do it from that place. So 2x plus 3 times x squared plus 6x minus 5. And right now it's just about making sure you don't get sloppy with your algebra. So 2x times x squared is 2x cubed. 2x times 6x is 12. X squared, 2x times negative 5 is negative 10x. 3 times x squared is 3x squared, and notice I'll kind of line up my quadratics. 3 times 6x is 18x, and then 3 times negative 5 is negative 15. Combine like terms, I get 2x cubed plus 15x squared plus 8x minus 15, just like that. Okay. Then h of x over f of x, so I'm going to do this. So that's x squared plus 6x minus 5 divided by 2x plus 3. And I would try and factor this if I could, but factors of 5, because they have to be, one has to be positive, one has to be negative, don't add up to 6, because 1 and 5, when one's positive and one's negative, either adds up to 4 or negative 4, so that doesn't work out. So that's not factorable. And this one we know is 2x plus 3, that's negative 3 halves. So nothing goes in with that. So if I could reduce this, I would. And I'll kind of point this out right now, that this answer right here, even though the domain of the first one is all real numbers, and the domain of the second one is all real numbers, the domain of this one is not. So just because you start with two things doesn't mean that the domains of their new process is still going to be. So the domain of this one is all reals, except x cannot equal negative 3 halves. Okay? Because that would give you a 0 in the denominator, and you guys know that that's a vertical asymptote right there. So all reals except for negative 3 halves is in that domain. So it's kind of what we're talking about right now. We can add them, we can subtract them, we can multiply them, we can divide them, And sometimes the properties of the parents hold through their children, and sometimes the properties of the parents are going to change once we have the children pop out. Okay? And I kind of point this out for some people. I have a wonderful blood disorder called hemophilia, and neither one of my parents have it, but it's a carrier on one of my mom's genes, and hemophilia simply means that my blood doesn't clot really well. So like if I took myself and I cut myself on my hand, it would bleed more than it would for normal people. Now, I just have something called mild hemophilia A, which means it's not horrible. However, if I do go in and have a surgery done or something like that, I do have to have special medication to help my blood clot. So paper cut, something like that, will bleed a little bit, but it'll stop over time. Kind of the general thing is clotting factor. I have about 11%, and a typical person might have somewhere between 50 to like 200 of this stuff. I have 11, so not real great, but just need to know that stuff. So again, that was something that we found out that affects me if I am this new result of this thing, but it didn't affect either one of the original parents. Okay. So again, addition, subtraction, multiplication, and division, and then knowing about domains and ranges and if they change or don't change. We know that right here, the domain of this one, we know that the number underneath the radical has to be positive, so we know that 4x minus 2 has to be greater than 0. So 4x is greater than 2, and x must be greater than 1/2. So the domain of that one changes. However, if I embed this thing, and that's what this stuff is going to be, so we have some relationships called f h of x and f following h of x. And basically what that means is we're going to take this function and we're going to pick up whatever h of x is right here, and we're going to shove it into the f of x function. So then it would be 2 times whatever, right? 2 times x. X is now this, x squared plus 6x minus 5. X squared plus 6x minus 5 plus 3. So f of h of x becomes 2x squared plus 12x minus 10 plus 3, or 2x squared plus 12x minus 7. Okay? F following h of x is the same. It's just different notation. Some textbooks use this, some textbooks use this. But it means that we're going to take the h function, whichever one's closest to the variable, and shove it into the other function. So does f of h of x and h of f of x equal the same things? And the answer is, sometimes. But for the most part, no. So now we're going to take f of x and shove it into h. So we're going to take this 2x plus 3 and shove it every place into here. So that gives me 2x plus 3 squared plus 6 times 2x plus 3 minus 5. And again, these two notations mean the same thing. And you'll see that this kind of looks like some of the stuff we did with the difference quotient, where we had to take an entire thing and embed it. Before we were embedding x plus h. Now we're going to embed an entire function. So again, this is called a composition of functions. Okay, so to combine them. 2x plus 3 squared, that's 4x squared plus 12x. Remember, because 2x plus 3 squared really means 2x plus 3 times 2x plus 3. So the inside of 6x and outside of 6x gives me the 12x. And then I got plus 9 plus 12x is 6 times this 2, plus 18 minus 5. 4x squared plus 24x plus 9 plus 8 is 27 minus 5 is plus 22. And that's what that one looks like. Good deal? So f of h of x does not necessarily equal h of f of x. However, if f of h of x did equal h of f of x, If that was true, then those two functions would be called inverse functions, and we'll talk about that again in another unit, especially when we're doing exponentials and logarithms. But that will be a key property later on in this course too. Okay, so the next thing we're going to talk about is this in implicitly defined functions. So if I was to graph this stuff, you're like, what the heck and bleep is that? X squared plus 2xy plus y squared equals 4. I'm like, I don't know, but we're going to see if we can find out what that is. We know that x squared plus y squared equals 4. If I was to graph that, that would be a circle. So maybe some of you are thinking, hey, that's a circle. But that's a circle. But I can't put it into my graphing calculator unless I get it in y equals form. So that's what I'm going to try and do, is I'm going to try and get it in, rewrite this as a function of y, because then I could graph it that way. Yes, I know, you could just plug it into Desmos and like, poof, hey, look, there it is. But we're going to try and do this, this process, okay? So what the technical term is called is make this an implicitly defined function. So in other words, can I write this as a y equals or as a couple of y equals functions? Okay, so first off, maybe you can see that this format right here is simply this. That's a perfect square, x plus y, good deal. And then I square root both sides, and I get x plus y equals plus or minus 2, because the square root of 4 is 2. And then I subtract the x, so y is equal to negative x plus 2, and y is equal to negative x minus 2. And you're like, wait, what? This isn't a circle at all, but it's some parallel lines? And the answer is yes. This function right here, if I was to graph that out on Desmos right now, you would see that it is a pair of lines, and they're parallel because they have the same slope, negative x, negative x. Good deal? Just been a vertical shift of 4 between the two of those things. Okay, so occasionally we're going to ask you to be able to see if you can take a function and write it, or take a relation, because this isn't a function. Good deal, because it fails the vertical line test. Take a relationship like this, or like this, and see if you can write it in just y equals format. Likewise, we could write this in y equals format like this. Y squared equals negative x squared plus 4. Y equals plus or minus the square root of negative x squared plus 4. So y equals square root of negative x squared plus 4, and y equals the negative square root of negative x squared plus 4. And you can see if we did these two things and put them into our graphing calculators, I'm going to do that like this right now. Where's my graphing calculator? Hopefully you guys have this on here like this too. So I go to my y equals clear and clear. We did this before, but this is good for you guys to see this again. So square root of negative x squared plus 4. And if I hit graph, oops, sorry, zoom 6, you can see it looks like the top half of a circle potentially. And then I do the bottom half, because remember, I can't graph it as one singular function because it's not a function. So I can graph it as two functions, which is equivalent to one equation or relationship. So the other one's negative, which should just flip it over the x-axis, right? Square root of negative x squared plus 4. Graph, and you can see, hey, that looks like a circle, and you're like, Mr. That doesn't look anything like a circle. And then some of you will go, but wait, that's because our window's wider than it is tall, and if we hit Z, we're going to zoom in first, so we can see it like that, and you're like, nope, still doesn't look like it, still doesn't look like it, does it? Looks like an ellipse, and then we go zoom 5, because 5 makes it a square window, and so now it looks just like a circle, and you're like, wait, there's not points here. Well, that's just because it decides to turn pixels on or off based on how close it is to a value, and that's too close to a vertical line, so that's why they're not there. If you graphed it on this thing right here, the newer calculator, it would show up a little bit better, actually, because it's a higher def screen. Okay, so good deal. So that's that. So I'm going to leave you with one little story problem here. And let's say that I had a picture that was 4 by 7, and another picture that's 8 times that area. And we know that on this one right here, it's going to increase to, let's make sure these things are centimeters. It's going to increase 2 centimeters a second for both the length and the width, okay? And I want to know how much time goes by until its area is 8 times as big. How many seconds are going to go by for that? Okay, does that make sense? Okay. So we know, let's see, this is 28, right? 4 times 7 is 28. So its area is 8 times as big. So let's see if we got something here. So I can quit. 8 times 28. We know the area needs to be 224. Okay. So the question is, I know the original was 4, and then it increased some amount, and this one was 7, and it increased some amount. So how much did it increase? Well, it increased 2 per second, t. 2 per second, t. Well, if I do length times width, then I think I got this. See if this makes sense. Focus in a little bit. 4 plus 2, t, and 7 plus 2, t, must equal 224 for however many seconds this is. Because again, so like 1 second later, this would be 6 and this would be 9 because it increased 2 centimeters per second. 2 centimeters per second. So 3 seconds later, this would be what it is. Does that make sense? So let's do a quick approximation right now. Let's see what happens. Let's say that this was 4 seconds. So that would give me 12, and then 8, that would give me 15. And if I do some quick math right here, 12 times 15, enter, is 180. So that quick adjustment tells me that it's going to be, should be greater than 4 seconds. Should be greater than 4 seconds. But then the smart part of me goes, hey, wait, isn't that just a quadratic? And that's just a constant. So if I graph it, it should be like this, and I should have 2 possibilities. One possibility is if t is negative, and hopefully you guys understand that we can just throw that one out, that t being negative, because I can't go backwards in time on that one. But that possibility, that might work for me. So let's do this here. So I use my handy dandy calculator because that's what our technology is for. In parentheses, 4 plus 2. We got to use x's. Remember, got to use x's here. Parentheses, and 7 plus 2x. And remember, my logic said it has to be greater than 4 seconds, right? Right. And then y2 is 224. Okay. So I go to my window, 0. Let's go -10 just so you can see that bad branch that's there too. And we can go to 10 because remember, I think it's going to be bigger than 4. So probably between 4 and 10 would have worked. Y max, let's go 300 and hit graph. And look, that looks reasonable right here, right? So this is the negative one that isn't going to make any sense for me, doesn't matter in this problem because I can't go backwards in time. But look at that one right there. Let's get just an approximation. I'm going to go up here, just get an approximation. Put it kind of by there. So that's kind of by there. 4.68 seconds. So we said it was going to be bigger than 4. Second trace, 5, enter, enter, enter. And I get 4.77 seconds. 4.77 seconds. Now, let's just check that 5. Remember, 4 gave me 180. Let's see what 5 gives me. So that would be 14 times 17. And on my calculator, clear, 14 times 17. That's 238. And you see that's bigger than 224. So logic said, right? 224 has to fall between those two things, so my actual time, which we got by solving that quadratic, had to be between 4 and 5 seconds. And that's how we do some problem solving. This particular problem right here is definitely on your homework, and I will know if you guys ask me, how do I do that problem? That you didn't watch this video, and all the people that watched the video know how to do that. So you guys take care. Hopefully this was helpful. Composition of functions, adding, subtracting, multiplying, divide them. Being able to write them as two implicitly defined functions. And little application stuff with some of these. Good deal. Okay, we'll talk to you later.